What's up, everyone? This is page 436. And in this video, we're going to wrap up, and page 435. We're going to write some geometric statements based upon all of the work from this lesson 3 on chords in circles. And so what I want you to notice is we have a direction in our lesson right here to write a biconditional statement. A biconditional statement just means that if you know an if-then structure goes one way, it might have an if-then structure that goes the other way, like you flip it, because it's called a converse, and both of those statements could be true. If-then and the reverse of the if-then being two true statements, we actually call that biconditional. So of the things that you needed to know from the videos, from the lesson, from the notes and everything, like the equidistant chord theorem on page 430, and its converse on page 431, we can write that as a biconditional statement if we use the phrase if and only if. No thens. If and only if. It's like, if this is true, then this is true, but if this is true, then this is true. And that is a directional statement that both directions are actually true. So I wrote it in two different colors, hope you can tell, and I put if and only if in the middle between those two colors because you could say one and then the other, or you could say the other and then the one, and it would be totally true. Two chords of the same or congruent circles are equidistant from their circles' centers if and only if the chords are congruent. Boom. Next, we have the conditional and the biconditional statement for the congruent chord, congruent arc theorem from page 433 and from page 434. Two chords of the same circle are congruent if and only if their corresponding arcs are congruent. We could flip that around to say, two corresponding arcs are congruent if and only if their chords are congruent. Good grief. Let's go to page 436, wrap this thing up. Let's go. Consider the problem from the way back getting started, the plate that Sarah was trying to determine its center, its radius, its diameter. You know what she did? She traced the edge of the plate. So we're going to trace the edge of the plate. She identified two chords and two chords. Then she found the perpendicular bisectors of those chords. And where those perpendicular bisectors meet, it creates the center of the circle. So you just measure that distance. It'll be the same as the other chords. It's not a chord now, it's a radius. Those two radii have the same distance. It tells you that this is the center, this is the radius, so you just double it to get to the diameter. Let's write that up in a sequence of steps. Number 1, trace the edge of the plate on the paper. Number 2, draw two chords on the paper from what was created, on the arc that was created. Number 3, construct perpendicular bisectors of those arcs to see where they cross in the center of the circle. And then that's the center of the circle. So you just measure from the center of the circle to the edge of the plate, the edge of the arc that was created, and you have the radius, and then you double it because diameter is double of the radius. Thank you for watching this video. Easy peasy lemon squeezy, you've got this. That's the end of our module 2. There's no more for me to share with you. I'm glad you've made it through this journey. What an incredible journey for you to go on with me in this video. Thank you for watching. Like, comment, and subscribe. You are awesome. And I will see you in module 3 as we continue geometry's journey. Yes, love it. Have a good day.